Hi, my name is Sandia and I'm proud to represent the Realtek Matter IoT engineering team. In these brief presentations, I will guide you through the process of constructing an Amoeba Matter SDK for your Matter devices. To provide a visual reference, here is how the Amoeba SDK integrates with the open source Matter chip SDK. At the application layer, we seamlessly merge the Amoeba Matter SDK with the Matter chip SDK. The Matter chip SDK is the collaborative effort showcased on the GitHub repository hosting the open source project implementation, gathering contributors from all over the world. You can access the official tag release hosted on the GitHub repository, allowing you to download, clone the source code for your product development. In today's demonstrations, we will utilize the Amoeba Z2 for our illustrative flow. If you would like to know more about Amoeba D, you may refer to the provided link for more information. Now, let's dive into the practical aspect of our discussions by showcasing how to construct and execute an Amoeba Matter example, ensuring seamless device compatibility. Firstly, Matter support is available on Linux, necessitating some hardware and software setup. Prepare an Amoeba board and a micro USB cable and ensure that our Linux environment is equipped with the necessary software as detailed in this presentation. Let's proceed by exploring Matter support in the Amoeba SDK. We will go through the link provided for the Amoeba Matter documentation, which is offering comprehensive information to walk you through the flow and build a Matter project. The Amoeba SDK and Matter SDK are tested on the Ubuntu 20.04 and 22.04 LTS. Start by opening a terminal in the directory where you want to store your Matter project, or create and enter new directory. Then, you may check out the Amoeba Z2 repository with git clone now. By copy and paste the command, you will be able to start clone the Amoeba Z2 Matter SDK. Matter is deployed as one of the Git submodule repositories, and we have a dedicated folder to provide synchronizations between the Matter chip SDK and Amoeba SDK. Copy and paste the command and start to clone the Matter chip SDK. Once both of the SDKs are ready, we need to make sure Amoeba Z2 Matter and connector home IP are on the same directory level. The next step is to build the Matter environment. CD to the connector home IP and ensure some module is synced and updated before we build the Matter environment. Now, we can build the Matter environment. Activate the Matter environment. Several examples like Overcast the app, Lighting app, OTA Request the app example are supported in the SDK. For this demo, we will use the Lighting app. Finally, build the targeted Amoeba Z2 SDK. See to the Amoeba Meta application first. Then, you may execute the maglite command. Follow with the Amoeba Meta application command macis_meta to build the application. Now, all the SDKs are ready, and you can find the image in the dedicated folder. For Z2, the binary file named as flash_is.bin, which is located at the project folder. You can now select to connect the device and flash the firmware to it. We have an existing download tool for you to flash the firmware, and you can follow this command. If you are interested in the image too, click on the provided link and the Flash Image section for more information and guidance. Open the device serial port using your favorite app, and I'm going to use Purdy. Ensure your device is in the download mode. Press and hold the UR download buttons, then press the reset button and release both buttons. Make sure the locked UR is connected properly. If the chip enters download mode, the below log should be shown on the locked UR console. Execute the command to download the firmware in the device. Now, let's have a quick demo for the commissioning with Chip 2 to control the light applications for you. To start the commissioning, open the Purdy and reboot the Amoeba Z2 board with the reset button. You may also use the ATM dollar commands to do the battery reset. Now tap the commands and do the commission over BLE Wi-Fi. After the commissioning is completed, you may execute the on-off commands to read some of the information out. In this demo, we are reading the on-off status. In this scenario, the on-off status showing in off status. If you face any build errors or to know more on the troubleshooting, you may refer to the application note 0204 for more detailed information. So, this is a summary of the setup project environment. Thank you.